All right. Yeah. Good morning. Yeah. Nice to see people here and excited and ready to go. Um, yeah, we're going to actually hear from other people today, which will be really cool. Um, awesome. All right. So presumably everybody has finished homework 7. I got lots of downloads from Git, which is great. Um, any questions or things you want to talk about as far as homework 7 or other stuff up front? Otherwise, I want to go over homework 8 pretty quickly and then go ahead and get into presentations. So, anything you want to go over first? All right. Well, let me do a quick run through on homework 8. We'll definitely talk about this more in class next week. Um, Could you show us how we could have done the import export feature? I'm not sure what the import export feature would be. Oh, you mean to send your calendar out to another form? Depends what you want to send your calendar to. But basically, you have an appointment book with appointments and dates and times and such. I'm not very familiar with iCal format, but if you have another calendar program that you use, you basically figure out what the file format is that program expects, and then it's just a bunch of file translation. Some of these are open formats, some of them are not. Um, but there's a variety of ways that you could do that. That was definitely marked as kind of a very ambitious additional feature. And I've never tried pushing stuff barehand into Google Calendar or something like that. But it's doable. But not something I can just spin some code off the top of my head for. Um, but you could output it to like a CSV file in some format that people could like read into Excel or something, or a plain text format with headers and things like that. There's possibilities for things like that also. All right. So homework 8. So as I mentioned yesterday, homework 8 is going to be a bash program, and it's going to be a program for taking input from standard in and breaking it into phrases and then giving you a report of how many times each phrase appears in the input. So it's like an index program that basically counts how often certain phrases appear. So there's a lot of detail here, right? Which you can read through and then ask questions about. But let me give you the high level overview. So this is a bash script. Call it main, and basically you run it and it reads standard in and it produces output to standard out. Let me show you a sample of this. So here's my program, so I can say this is a test. Right, and then I'm just going to hit Control D for the end of the input, and I get a list of cleaned up phrases. Everything is uppercase. Punctuation has been mostly ignored, and 3 of my phrases appeared twice, and 1 of them appeared once. Right, so it should do the necessary processing to clean up the input, right? Make things uppercase, get rid of special characters that we want to ignore, break things into phrases. So phrases basically begin, with the beginning of a line. They end with the end of a line, but they also begin and end at certain punctuation marks like commas, periods, semicolons, and so on. So they're more or less, what you would think of as a phrase in English. It's not going to be perfect. You can think of cases where this won't do what you would expect a phrase parser to do, but I've given you an exact specification and you just have to follow that spec. And your real goal is, take the input, clean it up, break it into phrases, and then create a tally that keeps track of how many times each phrase occurs. Okay. I don't have this test file in there yet. All right, so how do you do this? Input cleansing. Read a line of input from standard in. So just use the read statement, okay? Convert all the letters to uppercase, and you can do that with a command called tr. tr is going to be a good friend in this. Convert all the letters to uppercase. Remove any of these characters. All right. Easy way to do that. Use tr to convert all of these to something like, an @ sign, and then use sed to remove that. These characters, some of them are tricky to use with sed because sed has so many special interpretations. These things mean things in regular expressions. tr doesn't really care about regular expressions, so we can use tr to change all of these to a well-behaved symbol and just strip those all out with sed. Change all of your spaces into underscores. Get rid of consecutive spaces, make them just one space, right? And that's a sed thing. And then go ahead and change all your separators, just change those into spaces. So dot, comma, semicolon, colon, exclamation mark, question mark, turn each of those into a space. All right. Why are you doing this? Because this is going to take your input, it's going to turn it into a series of well-behaved phrases which are separated by spaces. And any spaces within the phrase have been changed to an underscore. So these just look like, long strings of characters. That's going to work really well with bash. All right. Step 2, you want to extract the phrases out of that big long line that you've gotten and done some parsing on. And here you can use a for loop. Okay, so this is a for loop that is allowed in bash. You can say for variable in space separated list of words do, and whatever you do in here, right, phrase will be the next piece of that collection of phrases. All right. And for each phrase that you find, you basically want to record how many times that's been seen. So if you've never seen it before, you want to save it somewhere and say, I've seen this once. If you've seen it 10 times, you just want to say, okay, now I've seen it 11 times. So you're building up a tally. And this is really, really easy to do if you use an associative array. And we won't talk about associative arrays in detail until Monday. But you can, if you want to work on this over the weekend, work on the parsing aspects, right? Work on cleaning the input, breaking it into phrases, getting this for loop going. And if you can write this for loop and inside here just print out each phrase, inside angle brackets, then you're all set to build a tally using an associative array. And that's absolutely trivial once you know how to use these hashes, these kinds of arrays. And there's some sample code at the end that will help if you want to dig into that over the weekend also. And a note here, before you tally the phrase, go ahead and remove all the spaces if you like. Remove those somewhere along the way. All right, then once you're done, basically go through your associative array and just print out each phrase and the number of times it occurred. And this is another for loop. This will go through your associative array. All right, that's really all there is to it. I'm going to change this. I'm not going to suggest you do this before you tally the phrase. I'm going to suggest you leave the underscores in there and then remove them down here before you print. So I'll make that change and update this. Anyway, series of test files. There's 5 test files under /temp, homework 008 tests. Test 0 through test 4. If you want to run your program with input from a file, just redirect standard in from a file. And I suggest putting it through sort-n, which will sort in increasing frequency of phrases, right? And you can save the output into a file, and then you can study it and see if the output's correct. So I've included 5 test files, including what the output would be from a properly working program if it was sorted. You're not required to sort it, but if you want to compare, it's easier if it's sorted. Okay, and part of your grade will be based on running these 5 test files. All right, git repo, homework 008, all the usual drill there. Pretty simplified grading rubric, so it's got to be a bash script, it's got to be submitted on time through Git properly, it's got to run on the Linux server, it's got to work on more than just the specific test cases. Don't just make something that, outputs the right output based on the input file. It's got to be, a general phrase index program. Reads from standard into standard out. Cannot exit abnormally due to any errors. Okay. If I start running it and it gets partway through and it throws up and hasn't output anything, then I can't grade it. Okay, so it's got to do these things at the minimum. All right. So points. If it's called main, you get 5 points. If it reads standard in and produces any output at all, you get another 15 points. So if you get something that just reads a line and says ha ha, you've got 20 points as long as it's called main. Okay. The output has to be formatted correctly, which is going to be a number, space, and then a phrase. That's 5 points. Don't produce any extraneous output. Don't say hello in the beginning. Don't print out the phrase, number. Don't prompt the user for input. No output except for the final tallies at the end. Okay, as long as you adhere to that, it's another 10 points. And then on those 4 tests, 0 through 3, I'm going to run those. Those are worth 10 points each. Test 5 is worth 5 points. That's a big test. That's the text from Wuthering Heights. And that's to make sure that your code doesn't blow up in trying to handle, a large number of input lines. And then commenting and coding style is worth 20 points. You need a block at the top with your name, the date, description of the project, and so on. That's 10 points. And then your code has to be indented properly based on nesting. You need to have comments before every section of code saying what this code block is about to do, and put comments on individual statements where needed. That's worth 10 points. All right, so that should add up to 100. And you can read this, but let me just emphasize this one part. There's not a whole lot of sophisticated logic going on here. Okay, there's not a lot of looping. There's not a lot of nested, if then else's. There's not, deep complex algorithms that are going to go, this if inside this for, inside this while, inside this if, right? It's a really straightforward process. You can do this in 24 lines of bash. Okay, it's about figuring out how you want to use these commands from bash, and so start early. Okay, I would get working on this over the weekend if at all possible. It's due a week from Monday. Okay, so it's a Monday morning due date, not a Friday. But get started on it early. Try to pretend that it's due a week from today, right? Shoot for that as an absolute deadline, and then, if you're running into problems, you can ask in class, you can ask in office hours. And if you miss that Friday deadline, right, I've still got office hours that Friday afternoon, right? And then if something really weird happens, if something strange forces you to go beyond Friday, you've still got the whole weekend. Okay? But don't leave this until, next weekend and start on Saturday. It's not going to work. All right. Sample code here for working with associative arrays. I'll let you look through that, and we'll talk about that in detail on starting on Monday. But the main things you're going to want to think about for this assignment, think about TR and think about SED. Those will do most of the work for you. And SED we've been talking about. Let me just give you a really quick idea of TR, A. Right? So this says translate the lowercase a to an uppercase a. And it reads standard in, sends the output to standard out. This says translate lowercase a through z respectively to uppercase a through z. Right, and so it converts things to uppercase. Right, this converts spaces to underscores. And so if you want to get rid of a bunch of punctuation, I could replace dot, comma, semicolon, colon, exclamation mark, question mark with, let's just change all our punctuation to be a period. Right? So if you want to replace single quotes, let's just replace it with an @ sign. Alright, so I can always put a single quote inside double quotes to be able to pass it through as an argument. And if you want to do double quotes, put it inside single quotes. And I don't think you can do this, right? But we can do this. Right, well, if I take this and I pipe it into sed and substitute my @ sign with nothing, right, that'll get rid of my quotes. So TR and sed work together really well. Sed will do, you know, all kinds of powerful substitutions, but it's just a little awkward sometimes for dealing with strange characters like parentheses and brackets and periods. And TR also lets you do ranges of things, in particular for converting to uppercase, right? And you can break this out one by one. Right, so here's right, here's a test 0. Here's a test 1, right? You can break these out, you know, one at a time. I can just say line equals this thing. Right, and then I can start playing around with this. So I can take this and pipe it into TR A through Z, A through Z, TR. Right, and hey, I've finished the conversion to uppercase. Right, now I'm going to take this and I'm going to do something else. I'm going to get rid of you know, trailing spaces or whatever. Right, so you can figure out what commands you want to use from the command line. Right. Get yourself a set of steps that work, and then just put it into a bash script. Right, and then test 5 is well, the 5th test. Test 4 is the big long file. So this is 500,000 characters worth of text. Alright, and then there's output files that show you what the output should be like. Alright, is that enough to get people started? All right, cool. The phrase, so read the description. The phrase basically ends when you get to the end of the line, or period, comma, colon, semicolon, exclamation mark, question mark. And however long the phrase is, that's the phrase. All right, and some of these will be pretty long. That's actually from Project Gutenberg. Right, but there's no limit to the number of phrases or to the length of the phrase. All right, and associative arrays will take care of all the hard work for saving those and tallying them. All right, so I'm going to post a different version of this. The only difference is going to be this business of before tallying, remove the leading and trailing underscores. I'm going to get rid of that. Right, leave those in while you're tallying, and then just take them out before you print. All right, cool. So I'm going to stop sharing my screen at this point, and I'm also going to stop recording.